Hello everyone and welcome back to my channel. In this tutorial I will show you how to create gears and how to animate them using joints and motion link. I have already created a video about gears, but this time I'll go into more detail but not too deep, since it can get quite complicated depending on what the gears are for. By the end of this video you will know basic terminology, what tools Fusion has to offer to create gears, how to figure out the number of teeth for a specific gear radius, how to calculate tooth size, and how to animate the gears. So before we begin, I just want to remind you, don't forget to subscribe and hit the bell icon so you can get a notification each time I'm releasing a new video. So let's begin. As you can see here, and this is what we are going to create. So I've got those three gears, three different sizes, and I'm just going to turn this one around. As you can see, they are meshing really nicely and everything works as it should. So this is what we are going to create today. So we're going to start with a new file. The first component that I'm going to create, later on you're going to understand also why, but I'm going to do some sketches over here. So I'm going to call it drawings, and we're going to start with a new sketch, and it's going to be right here. Now, as you know, when you're creating gears, they're going to be inside an enclosure, some kind of a box. And so, which means they also have some kind of limitation. So we need to also going to help us to figure out what size of gears we need. So I'm just gonna keep it simple, and I'm gonna draw a rectangle right here. I'm gonna give it some dimensions, and this one here, it's going to be 200. Like that. Now I also want you to pay attention, those are going to be relatively large gears, and so yeah, take that also into account later on. Next, what I'm going to do is we're going to create one circle in this side, another one on this side, and another one on this side. We're gonna do some constraint, and this one I'm gonna constrain to this point right here, and this one to this point right here, and this one vertically right here. Next, I'm going to create some tangents, and it's gonna be between this one and this one, and this one and this one. And don't worry, we're going to give them some measurements. So this gear is going to be 60, and this one is going to be 148, and this one going to be 100. Now of course we can move them a little bit to the side, but I'm just gonna keep them as it is. Now the sizes that you see here, this is not the outside diameter. What you see here, it's called a reference diameter, and sometimes it is also called it's got other different names, and I'm going to show you right here what the other names. You can see here it's also called pitch circle, and I think it's got also other names. So, but the names can be a little bit confusing sometimes. It depends what kind of measuring system you're going to use. So that's why try not to be too much fixed on the names. Try just to understand what they are representing in general when we're talking about the sport gears. So this one, for example, that we just created, it's the pitch circle, and it's quite important diameter. This is where we're calculating also in general the size of the tooth itself. Now before we continue, So that's what I want you to bear in mind first of all, okay? And you're probably gonna make some changes later on, so don't worry about it. Maybe in your case you're gonna do some changes, but the difference between this one and the outside diameter, it's about 2 millimeters, so it's not really that large. We can always change things later on. So this is the basic information that I'm gonna need for now. So I'm just gonna finish this sketch, and I want to show the dimensions. I want to see them. Good. Now, second thing we need to figure out is what kind of tools Fusion offers us to create gears. So we have two options. First, we have the built-in gear plugin that you can find under tools. Then you click on add-ins. If you scroll down, you can find it right here. Click run, and this is it. The second one, it's the one that you just saw right before. It's right here. If you go to the App Store, don't worry, I'm gonna put all the links in the description. And this one called FM Gears. I'm gonna use this one, and the only reason I'm using it, it's instead of always going to tools and add-ins and bring it up, after you install the FM gear, you're gonna find it under create and FM gear. Now, there aren't really that huge difference between them, but the FM gears can offer you also an internal gear and rack gear if you want to create one of those gears, okay? But in general, they are very, very similar, the same information. You can see here the standard, you can choose between metric and English, and you've got the pressure angles and so on. So we're going to use the FM gear. Now, how can we move on with this information? And for that, there is a really good website. I'm gonna add this into the description. And this website is gonna help us to calculate all kind of information. For example, right here, it's the pitch circle. If you are looking to know what's gonna be the pitch circle in a situation of X number of teeth and our module. Now the module, this is basically mean the size of the teeth, and you can also see it right here. You have again, it also has another name. It's called diametrical pitch. That's an English unit, or module in metric units. So if you know that, you're gonna put it in, and that's gonna give you the measurement and of the pitch circle. Or you can also do the other way around. But in our case, we already established what is our pitch circle right here to all of them. So now we need to figure it out, the size of the tooth itself and how many teeth we are going to need. So there are several ways to do this, and this one is going to be relatively easier. So we know this is what we are looking for in general. Yeah, we need to achieve this 148. So we can do some basic, calculation and play with it and see, okay, if I'm going to use module 2, so 148 divided by 2, that's going to give me 74 teeth. Now, if you want to check this out, there is a really good website, and it's not this one, it's right here. You can plot the information right here. You can see the number of teeth, so it's going to be 74. Then diametrical pitch, was 2, and basically this is how it's going to look. This is gear number 2, so it's this one right here. Okay, so you can also add a few gears here and then play with them. You can change their position as well. Yeah, so this is a really nice tool to work with before you're going to plot it into Fusion. So I figured out that I want to work with module 2, and I'm going to have 74 gears, and the pressure angle, I'm going to use standard 20 degrees. Next thing you have to remember, it's very crucial that if you want gears to mesh with each other, then the module, which means the size of the gears, the size of the tooth itself, and the angle, they must be the same for all the gears. Otherwise, they're not gonna mesh. They're gonna look different. Okay. So remember the module, if you're going with 2 or 0 point something or 4 or whatever, you have to keep using it to all the gears. Okay. The number of the gears doesn't matter really that much, as much as the module and the pressure angle. So we're gonna keep it pressure angle 20 degrees, and we're gonna use 2, in this case, the size of the module. Next, in regards to terminology and everything, what it means, how to calculate stuff, I found a really good website. It's going to be this one. I'm going to put the link to this into the description. And you can see right here, it's explaining exactly what it actually means. For example, the module, if you take the module, let's just say 1, it's just a designated number, and you multiply it by pi, you're going to get these numbers, and that's going to give you basically the pitch. And so you can do all kind of really go into deeper what everything basically means here, and understand a little bit more how to create those gears and what it's actually mean, the different parameters. But I don't want to go too much deep into this, because then the video is going to be very, very, very long. So I'm just going to keep it as simple as possible. So we already got our first gear right here. So we just need to plug the information into our plugin. So we know that it's 74 and 2. So we're going to our create and FM gears. So as you can see right here, we have metric. But if you want to put a hole inside the middle, do that. I don't want. I'm gonna create all this kind of stuff later on. Now pay attention to this pitch diameter. This is this one, okay, that we have created. And we're gonna use metric and gonna use 20 degrees. The module, it's gonna be 2, and the number of teeth, it's gonna be 74. And as you can see right here, 148, which basically it's matching our gears, the circles that we have just created right here. Right here below, you can put root fillets. If you want, you can do it now or you can do it later, depends on you. Gear thickness, I'm just gonna keep it 8. And in the other plugin, the one that is built in Fusion, it's also gonna give you a option for backslash. This is basically kind of clearance. It's very important, because right now, as you can see, they are touching each other. That means that it's very, very tight, and it's always a good idea to give it some kind of a backlash, especially if there are kind of gears that you're gonna need to use some lubrication. And then if you don't have this clearance, the lubrication won't be able to go inside, and it can be also quite noisy, the gears. So you should give it. And in some place I read, I think it's gonna, the standard is like 0.25, something like that. I'm just gonna keep it as it is right here, and we're gonna click OK, and the gear has been created for us right here. So what I'm gonna do is I'm just gonna use the come back, click on this one, and hit the M on the keyboard, and I'm gonna orient it like this, 90 degrees, and I'm gonna move into point to point, and I'm gonna go into this gear, and I'm gonna hit the control, choose this point, and then I'm gonna choose this point. So now they are aligned. I'm just gonna capture the position, and here you go. Good. Now we need to work on the second gear. And so we're going back. We know that it's 60. So we're gonna go back to our page here, the calculation. So we know we need to figure it out So it's going to be 60 right here, which means 60 divided by 2. If we're going to put 30, so we already know that it's going to be 30 teeth. So again, going to create FM gears. It's 2, and this one is going to be 30, and this one it's still 0. That's good. I'm going to click OK, and we're going to do exactly the same as we did before. Just gonna orient this one 90 degrees, and that's what we're gonna do also for the last gear. Now I'm gonna hit on the control in order to catch the points right here and choose this point over here, capture position, click OK, and we're going to create now the last gear, and this is diameter of 100. Create FM gear, and so we know that it's going to be 50, and that's going to give us 100 because it's 100 divided by 2. 100 divided by 2 is going to give us 50 teeth. So yep, and we're going to click OK. Choose this one, hit the M on the keyboard, orient this 90 degrees, and we need to position it. I'm hitting the control, choosing this point and this point right here, capture the position, and OK. So we've got our 3 gears, and this is how it looks. I can just hide this one right for now. I don't need it. So our gears are being created. Now, as you can also see, the name of the gears gives you also the number of teeth. So if you're wondering, and it's also can be a really good idea if you don't remember exactly how you create them. So, you know, we can always put for example, M2. So you know that it's module 2, 74 teeth. Okay. And if you multiply, then you know the pitch diameter. Okay, so we finish creating our gears. Next, we need to create some joints, and I'm going to use the as-built joint because they are already positioned where I want them to be, and it's not going to be rigid, it's going to be revolve, and we're going to choose this component to this component, and it's going to be revolved around this one here. Next, I almost forgot, I want to ground this one. Good. So now it's not going to move. Okay, as you can see, it's not moving. So we're going to do the same for the second gear. It's going to be this one to this one, and it's going to revolve right here. And the third one, this one to this one, and it's going to be revolved around this, and we click OK. Now, when we are in this position right here, if you want, you can just move it by hand right here, position it like this. This is virtually, so it really doesn't matter, because you know in real life when you're going to create it, they are going to match, they are going to be positioned as it should. So it's mostly you know, aesthetically. So I'm just going to do it by hand, and I'm going to do I'm going to capture the position, and I'm also going to do right here like this, and it's good enough, and I'm going to capture the position. So now how can we make so they are going to move together? And it's very easy. So we are going to again click on assemble, and we're going to motion link. We're creating the movement in relation to 2 different joints. Now this one, it's actually very, very easy, and some people, I don't know why they're kind of getting a little bit confused here. It's all about ratio. It's if I'm going to take the big wheel here, okay, the big gear, if it's turning 360 degrees, how many times the small one is going to turn? The calculation, it's very simple. So you take 148 divided by 60, and that's going to give us the ratio. Okay. And so how are we going to do this in practice? So we're going to choose, and now the first one is very important. Okay. Which one you choose first and which one is second. So that means that we're saying if we're choosing the first one, that basically means, okay, if this one turns 360 degrees, now the second one, how many turns it's going to have. And it's not going to be 360. As you can see here, they're not exactly matching. So I'm just going to stop this one for a second. For now also, as you can see, they are turning correctly. If it's not turning correctly, then you just click on the reverse. So how are we going to calculate it? So we're saying, okay, this one is going to turn 360. And so how many times the second one is going to turn? So we're going to, as I mentioned before, and we're going to do some simple calculation. I'm going to show you. So we have 148 divided by 60. It's 2.466666. And if you multiply this one by 60, that's going to give us 148. Okay. So it's 1.246666. So what we're going to do, we can put, for example, 1 here, and we can put 2.4666, for example. Okay. And we're gonna do the reverse, and it's basically the same. If I'm gonna, it's much easier instead of to put, one huge long angle. So I'm just gonna say, okay, for 1 degree, how many degrees the second one is going to move, and it's going to move 2.4666. Okay, so if I'm gonna zoom in, you can see it much clearly. Oh, sorry. Oh, I need to turn off this one. Good. So as you can see, it's matching perfectly. So again, it's just a question of ratio. So we're taking either the small one divided by the big one or the opposite. It doesn't really matter. It's going to be exactly the same. So I'm going to do this now the opposite way. I'm going to go to motion link again. So I'm going to start, for example, with the small one, and then the second large one. So we're saying that the small one, let's just stop it. We know that it's 60 and this one is 100. So if this one making 1 turn, the small one, how much the second one is going to turn? So what we're going to do is we're taking 60 divided by 100. So it's going to be 0.6, which means here we're going to put 0.6 turn. And if we test it, well, it's moving really, really fast, but I'm just going to click OK, and you will see that it's actually working. But right here, it's not working because it's going the other way around, because it was moving so fast. So I didn't see that. So we're just going to edit it, and you're going to do reverse. And this one is hidden. So as you can see now, it's working nicely. So 1 degree gives us of movement. This one, the bigger one, it's moving 0.6 degrees. And if we put everything together right now, as you can see here, so everything works nicely and mesh together. So as you can see, it is very, very simple. It's really not that complicated, at least creating the motions and everything. What's in general complicated when you're talking about gears, it depends on the applications, because sometimes you need to calculate the size or the number of teeth based off the, for example, speed and stress and stuff like that. This is where things can get really complicated. But if it's a fairly simple gear, then you don't really have to think that much about it, especially if you need to recreate a gear that's already exists. So you would already have most of the information. And again, you can use this page here to learn exactly all the terminology, what exactly they mean. And I also have another forum here where people discuss the gears. It's a really good one. You can see how we can do the different calculations here. And yes, what else we have? Yeah, so as I mentioned, what I wanted to show you right here is how you create gears in Fusion, how simple it is, and how you can use this page in order to calculate different parameters. For example, here you can, if you want to look for the number of teeth, so if you know the outside diameter and you know that the model is going to be 2, and so the number of teeth are going to be 48. Okay, if this is where you're going to start, you say, okay, I don't know, I don't care about the pitch circle, but I know that the outside diameter it's going to be 100, and I know I'm going to use module 2. Now I want to know what's the 48, the number of teeth is going to be. And then you can take this 48, put it right here, and you can see the pitch circle, it's going to be 96. Okay, so it's like 4 millimeters distance between them, difference between them. So yeah, and this is how we can continue if you want to figure it out the outside diameter. So when you already have the number of teeth, just plug in here, 2, and yeah, but this one it's right here, it's supposed to be like 48, and here we go. And you can also figure it out the distance between gears. You can just plot the pitch circle right here, and this one is just for if you have an internal gears, so you can use this calculation area. And yeah, this is it. It's very, very basic and very, very simple, and it's quite fun to work with. And yeah, so this trick right here that I've created, I'm working with it sometimes if it's relatively basic stuff, and it's good because you're creating like a drawing, first of all, where the things are going to be, and it's going to give you a really good what you can say, good way of for example, positioning different components. So you can use that both in drawings and for positioning. Okay guys, I hope you enjoyed the video. Don't forget to subscribe and hit the like button. If you have any comments or questions, then please write it down in the comments area, and I will see you in the next video. Cheers.